Right. Have a good day, all of you. So today we are going to discuss on the topic actually. So how to analyze your findings. So far, I guess you have now collected your data. If you are doing your research under the secondary type. So then today we are going to discuss about how to analyze your findings by using EViews. So then today I mainly focus on how to analyze panel data. So using EViews, because we have different kind of softwares, SPSS, data, so then we can use them as well. But especially like panel data, so we are mainly using sometimes data or EViews, right? So then this is another important areas in the regression as well as the econometrics analysis. So then actually, as you are aware, because we have learned the research methodology subject, so we have different kind of data sets. Hope you all are aware of that. The first one is cross-sectional data types. We can do the survey and we can collect the data. So then we call them as cross-sectional data. And we have time series data. And another thing, the final one is the panel data. So then hope you are all are aware of that and the meaning of the cross-sectional data and time series data and the panel data, because I'm only just discussing on how to do the analysis part using panel data, sorry, how to do the analysis part for the panel data using eViews, right? So then just I'll brief you about what is mean by panel data. So and basically, you can see the definition. Panel data is data set in which the behavior of entities are observed across time. So then simply, so we can say that the panel data analysis, so the panel data known as longitudinal or cross-sectional time series data, so that involves examining the data that follow the same objects or same subjects over multiple time period. So actually, this type of analysis is useful in econometrics as well as social sciences and this kind of researches. So hope you have now you are doing research under the second data type by using some variables. They are changed over time, but those variables are constant within the subject. So actually here you can also see the panel data allows you to control for variables you cannot observe or measure, like cultural factors or differences in business practices across companies. So then here actually we have key advantages. So you can also see, and hope you all are aware of that. So we can control for the unobserved differences or heterogeneity, right? So you can see the variables that change over time, but not across entities like national policies, federal regulations, and international agreement. So especially this panel data is useful for the unobserved data. So then we can control them. So we can track in the same subject over time. The panel data can control for unobservable variables that do not change over time. So then another thing, actually panel data allows for the study of dynamic behaviors and also the impact of past event of the future outcomes. So then this panel data is so important, and sometime, so as I mentioned earlier, panel data directly allow you to control for the variables you cannot observe or measure. So then actually it is you can see we can get some information from the secondary sources and by the time framework, right? So then we can analyze them by using the EV softwares, right? And another thing, so you can see this is its account for individual heterogeneity or unobserved effect. It means we can say simple word we can use for the individual heterogeneity. So it means individual differences. So we can analyze them. So then after you can see the balanced panel and unbalanced panel. So actually balanced panel and unbalanced panel means I'll just explain by using one example. So let's say we are talking about GDP and foreign direct investment in a South Asian country, right? I just take the topic, the impact of the foreign direct investment on GDP in South Asian country. This is just example. So then I just select as South Asian countries, India, Sri Lanka, Pakistan, likewise, I'm taking the countries. Then as example, for the Sri Lanka, I'm collecting data from 2000 to 2019. So then, and also I'm collecting data for the Pakistan. So year 2000 to 2019. So it says that we are collecting same data set for both countries. So then such kind of thing we recognize as balanced panel. So then we consider about the unbalanced panel, you know that sometime some we miss some information or we were unable to collect the data for some part, so then we have the missing data. So such kind of panels we recognize as unbalanced panel. So then this is the basic understanding of the panel data before we move into the uh, analysis of the panel data by using EViews. Actually, we can do the panel data analysis by using Stata as well. So you can use the most convenience one to you for the analysis purposes for undergraduate research, right? Okay, so then we'll discuss this panel data by taking one example. Right. So you can see the model specifications to the panel data specifications. So if we think that unobserved effect model based on the random variables and the time series variables, so you can see here the model, right? So I just have written here, right? So then you also familiar with this regression equation. Hope you are in your study also you have this kind of regression model. So then let's assume like I take the example. So that means actually, if you are talking about GDP in South Asian countries, so GDP is dependent variables, and we consider earlier foreign direct investment, so the FDI as independent variables. So then here YT or Y means, as per our example, so Y means GDP. So then you can see here, uh, y depend on the mean value, or if the mean value of y depend on subscripts of I and t, right? So then we need to discuss about the meaning of I and t, right? So here what is our example or the topic what we did, what we take here. So if we are talking about GDP in South Asian country, so GDP y is depend on this may be for Sri Lanka in South Asian country. So let's assume we are taking the countries Sri Lanka, right? Sri Lanka, and then we are considering the Sri Lanka for year 2000, right? Then here I mean Sri Lanka, the country we selected, and T is time period for this example, right? It's vary with the example to example. So then we can get the India. So then I will be India. Then here we assume that 2001 we are taking. Then T is 2001 is the T, right? So then that means, so this is the dependent variable you are taking the GDP. Then after Y and T, the subscripts of Y and T denotes what? The particular, according to this example, I denotes the country, T denotes the year. Right. So in your example also vary. Sometimes some students are taking what we call the uh, let's assume they are collecting data for the manufacturing companies. So then I will be the manufacturing company, then T will be the time period, right? Particular manufacturing company, let's assume the another company, you can select any company as manufacturing or material sector company. So then the particular company will be I, then the time period you are selecting or you are considering will be considered as T. So then after you can see the beta values and the explanatory variables or the independent variable with I and T for the particular company as well as the time period. Likewise, you can see here the independent variables or the explanatory variables. So you all are familiar with this kind of regression equation. So I'm not going to discuss in detail since uh, my duty is to explain how do we analyze the panel data by using the EViews. And also you can see here the constant value as well, right? So this is the example I have selected. So then we'll discuss about the practical example with the data. Directly we move into the EViews, right? Okay, so then please wait. I will share the Excel sheet with you. Right, before moving to the example, I thought to discuss another important thing with you as I mentioned earlier here, dependent variables, and then after the explanatory variables or the independent variables, and also here CI means the unobserved effect. So with that, actually, I hope to discuss with you. It means individuals, indifference, the differences, or the unobserved heterogeneity, and also we have the error terms as well. So then I hope to discuss on random effect and fixed effect. Random effect and fixed effect. This is also another important thing when we do the analysis part for the final data by using EViews. So as well as start. So then here, so mainly this is actually mainly talk about only our treatment on this CI value. It means unobservable effect, right? According to the formula, you remember here. So we need to consider on CI, unobserved effect. So this is all about our treatment on CI value. And also, simply, this is a discussion about whether CI be treated as a random variables or a factor that doesn't change over time. So then we need to just look at that matter first, then after we can go to the example. Yeah, discussion centered on whether CI is random variable or parameter to be discussed, right? So here you can see originally the discussion centered on whether CI is properly viewed as a random variable or as a parameter to be estimated. So then we need to check it first. In traditional approach, in panel data model, so we assume CI is a random variable. So therefore, it doesn't systematically affect on dependent variables. So then we treated it as random effect. But if it is not random actually, so if it is kind of parameter CI to be estimated, so then we consider it as fixed effect. So that is the difference in the traditional approach. And so then with the large number of random draws from the cross sections, it almost always makes sense to treat the unobserved effect. So then CI as random draws from the population along with YIT and XIT. Our concern here is what? So when we are moving to the fixed effect or random effect, whether this CI is related with other variable or not. Simply CI is related to other variable or not, right? So then, so here, wait one moment, what is you can see the random effect is synonymous with zero correlations between observed explanatory variables and the unobserved effect. So that means the covariance between independent variables. So this is so important. So here, simply we can say that the covariance between independent variables. So explanatory variables mean independent variables. So, and the unobserved effect are zero. So then there is no relationship between unobserved effect and the observed explanatory variable. So the independent variable. So then we can treat CI as individual random effect. Then we can use random effect approach to estimate the beta value of this model as well. So then in that case, we put this CI into error term, right? CI into error term, because if there is no relationship in between X and C, X mean observed explanatory variables or the independent variables, and C mean unobserved variables or unobserved effect. So if there's any no relationship in between these two variables, so then we can put CI into the error terms. That is because, so it means if we give the expected given error term is zero, uh, because there is no any relationship between X and C. right? So that is all important because we need to check whether there is a relationship between observed explanatory variable plus and unobserved effect. If there is any variable, if there is any relationship, then there is a problem. The next thing is fixed effect. Actually, that is other things. So in here, fixed effect doesn't usually mean that CI is being treated as non-random, right? We are not considering that. We are not assuming, or the CI does not mean it is non-random. So then it means that one is allowing for arbitrary correlations between unobserved effect CI and the observed explanatory variable X. So here earlier we discussed under the random effect, we assume that there is no any relationship. It means the particular CI value, we can put it as error term. But here, the covariance doesn't equal to the zero, right? Covariance doesn't equal to the zero under the fixed effect model. So if it is not equal to zero means, so we need to use the fixed effect model. As example, we can get ability and educations. So then ability has unobserved effect, then education as observed factor. Then you can see that. So these two may be related. So then we cannot say that, we can't assume that there is no relationship between explanatory observed, explanatory variable, and unobserved effect. Then, so it called as, if it is called an individual effect or a firm effect, then for practical purposes, this terminology means that CI is allowed to be correlated with X, right? Yes, now we can move to the example. So here you can see, let's see how do we use the funnel data analysis with the example. Suppose a researcher is interested about the impact of international trade on economic growth in South Asia. So then you are given the model specifications as follow. So then the dependent variable is what? Growth, GDP growth, GDP of the particular country. So IT means, as I mentioned earlier, here we are considering on South Asian country. So then I is the particular country, and also the T is time period, right? Time period. Then after you can see the beta value, and they are independent or explanatory variables for the beta 1 and beta 2. There are two variables, independent variables you can see here, right? GDP is the dependent variables, and I is country, T is period. Then the trade GDP is considered as dependent variable. So then trade as a percentage of GDP for the country. I is country and T is period. And also another one is labor force, considered as independent variables. I took this as example, right? So then labor force, then again I is country and T is period. And also you are given the beta value as well. So next you can see here the constant figure as well, right? And error terms also you are given here. You have also developed with your research topic for the, if you are using the panel data under the second data type. So then you also have this kind of uh, formula regression equation, right? So then I have collected data by using these data. We'll see how do we apply this kind of collected data with the EVs, right? Okay, so then right. Right. Um, Here actually you can see the way I have developed the table, right? So if you want to do the panel data analysis, so look at the way I have recorded the data. So this is must, right? So you have to record your collected data in this way if you are going to do the panel data analysis with EViews. Right, then first one, based on our topic, right, we have a country. We are going to test the GDP growth in the South Asian countries. So then we have selected two variables, independent variable, trade growth as well as the labor force. And this is the dependent variables. So then you can see, first we have to put the first observations, right? So if you are collecting data from companies, let's assume that HCL Plastic, like, right, just I take the example, then you have to put the company name here. You can keep a code for the particular company. Here, for the country, I have put for the Bangladesh, BGT, right? You can see BGT. And next you can see the country ID. Country ID. For Bangladesh, I have assigned one as their country IDs. This is necessary, right? So if you have only country names, we cannot indicate that, simply EVs doesn't recognize. So then we should have the country ID for here. For if you are having a company, you need to give a company ID, right? So you can get the 1, 2, 3, 4 likewise. Then country ID. And then after you can see the year, right? Year. So you can see here for the Bangladesh, first you have to put all the recorded data for the country 2000 to 2013, right? For the Bangladesh. And next you can see for India, the second one, India, the code is IND. Then country code I have given for India is 2. And also the next data for the particular data for the India from 2000 to 2013. So this is actually balance panel. For the Bangladesh, we have 13 years, and also India also we have the same way. And the same data we have collected. But in Sri Lanka, you can see here, some data is missing, right? Some data is missing. I just put num. So then this kind of data we recognize as unbalanced panel. You remember if there is any values are missing, so we recognize it as unbalanced balance. So then for the application, right, for the analysis, I just put numbers, right? Don't do your this kind of things for your research, but I just put numbers because three numbers are missing. This is actually I developed for your workshop, right? Only. Then after, so you need to open the EViews. EViews in your uh, computer, right? EViews in your computer. Right. So this is the interface of EViews, right? This is the interface of EViews. So then first you need to close this document. So then actually I just need updates, or no need to keep putting this. So then close it. Then after you can see here the EViews interface like this. Right. Then now we have the Excel sheet and also the data sheet and also the EV software as well. Then you need to import the particular Excel sheet or the develop Excel sheet to the EV software directly, right? You can do it. So let's see how do we do that. Click on file here in the left corner. You can see the file option, file. Then you can see here the option new, open, save as, and then import. Then import file. So then you have to browse the particular document. Then I remember I have in my document in the desktop. So desktop EViews. There I just select the data set number 1. Then after selecting that particular data set, you will appear this kind of window, right? So then here you can see the country ID, years, GDP, and all the things are recorded. Then tick on next. And also then after you can see the header line is, for the first one appeared the header line. It means the topic. You remember we selected in Excel as well in the label tab. Here also the same. It appears that the first one highlight the headlines of the particular Excel sheet, right? And next. Then after you will appear this kind of thing. Here an important thing, please check in the basic structure should be appeared as dated panel. So it means this EViews software identified that the data set you have put here are dated panel. Otherwise, the structure will be changed. You can just put it, see here, right? Undated panels and unstructures and undated panel. Likewise, the based on your Excel sheet. That is why I earlier mentioned you need to develop the Excel sheet. What I shown you in my Excel sheet example, right? First, you have to mention the country. In your case, you can put the company name and you can see the format. And also the identifier series also you are given here. Cross section ID series is country, and then after data series is year, right? Then after you can tick on finish. So then you will receive this kind of thing. Then click on no. Right. So then after you can see this is the you can see the informations, all informations are appeared in this EViews software, right? All the variable, constant, and country ID, and all the Excel what we have included in the Excel sheet, everything included in the data set, right? And also 56 observations are there. 56 observation means you can see the range 2000 to 2013, the number of years, then 4 countries, then 56 observation are there. Then 14 observation per country into 4 means 56 observations are there. So that is what also you can see here, all the observations are there in the Excel sheet, right? First look at that and please follow the way. How do we import the Excel sheet? The important thing is you need to develop the Excel sheet according to the table I have shown to you, right? Okay, so then right. So then first thing you can look at the descriptive statistic for all the variables. So here we have 3 variables, ne? So 1 dependent variables and 2 independent variables. So then how do we do that? Let's look at how do we do the descriptive analysis. So then first you have to select the particular variables. We have 3 variables. First thing is so select the variables while pressing control. So then the first GDP, then press control and labor force, and then after trade GDP. So these are the variables we have to do the descriptive statistic. Then after selecting the particular variables, then right click on that, right click. Then you can see the option open, right? Open. Then there you can see as group, equation, factor, var. Likewise you have, then click on group. So then after you can see all the observations in one table like in Excel, right? And you can see the country and their observations and also the particular variables values, right? Then after, how do we find out the descriptive, how do we do the descriptive statistic? So in the appear data sheet, you can see in the view option, right? View option, click on that. There you can see the view, under the view, descriptive statistic. Descriptive statistic. Then click on, and then after clicking this descriptive statistic, you may see common sum. Then click on common sum. Then after you can see general information, general is descriptive statistic for the data set, right? Mean value, median, and then after maximum, minimum, standard deviation, skewness, cortices values, and some observation, the number of observation also you can see 56, right? So this then you can interpret these results, right? Based on the mean value, you can include this under descriptive statistic. Then after you can interpret the results. So what is mean by mean? Mean value you can see based on your results, right? Median, maximums, minimum, standard deviation. Likewise, based on the results, you can put your finding into your research report. So then after you can interpret. So this is the way how do we do the descriptive statistic, right? So here, if you want to see the behavior of the data, so you can see it, right? So click on view the same way and drop. So then after you can drop the multiple chart right here, basic graph type, graph type is basic type. Then after click on multiple series, here only appear the single graph. So then click on select the multiple graphs and okay. So then after you can see the each variable's behavior, behavior. So you can include this in this to your report as well based on the behavior. So how much deviate the results year to year, likewise you can include those things into your report, right? So if you wish to include them, you can include in these things in your report as well. And next one, if you can right click and you can copy this particular chart and paste into your report, right? So then next one is what the as first step we need to check. We have checked the descriptive analysis, so then we can move to the PowerPoint presentation, right? PowerPoint presentation. So there you can see this is the example that we have conducted. Then descriptive analysis we did. Then next we have to test the panel unit root test of the each variables, right? So we have to test the panel unit root test, unit roots of the each variable. So this is also vary with the T and N. I will explain later. So what is T and N and how do we do the panel root test? So then we have option to do the panel root unit root test. So if you are having a balanced panel, so we need to do the Levin-Lin Q test. It means LLC test. So if you are having unbalanced panel, so then we need to do the Inference Sin test. It means IPS test, right? So then you remember we have balanced panel, balanced panel because I filled out the empty missing value as well. So, but don't do that kind of things in your research, right? If you are having an unbalanced panel, you need to do the Inference Sin test, right? So why we are doing the, why we are testing the, why we are doing this panel unit root test to measure the stationary, right? To measure the stationary. And so that actually we need to do the panel unit root test. That is actually statistical method that used to determine whether a panel data series, contains or the data set that follows the multiple subject over time. So contains a unit root. So that the presence of the unit roots implies that the data series is non-stationary. So it means actually that means statistical properties such as so mean and variance change over time. And also if there's any non-stationary data can lead to misleading the results in econometrics analysis. So therefore this unit root test is crucial for the testing analysis part. So therefore we need to test the unit panel unit root test as well, but it is also depend on your number of observations or number of time series observation or the time dimension, right? So I'll explain with you later about the T and N, right? So then we can test it for the, so this is balance panel, so then we can do the Levin-Lin Q test, right? So yes. Right, first we need to do the GDP growth rate, right? So then the same way, first you need to select the data, right? Double click on the data. And then after you can tick on view. There you can see the unit root test. So then in the test type, you have options, right? You have options, test type, summary, and you can select this. So then you know that we have balance panel. So therefore we need to do the common root Levin-Lin Q test. You remember. So then click on this. And then after the test for unit root, in first time you need to do the unit root test for level, click on levels, and the include test equation is individual intercept. Then okay. So then you can see the Levin-Lin unit root test, and you can see the total balance observation we have, balance observations. So this is balance panel. Then so you can see the probability value as well, right? So balance, you can see the probability value as well. So then we can here, you can see the, I need to explain that part as I mentioned earlier. So we need to see the T and N. right? T and N value. So T is the number of observation per country. So you can see here the total observation 48. We are having 48 total balance observations. Then 48 divided into 4 means 12 observations are there. Then T is 12, right? T is 12. Then after N means 4. N means the number of cross-sectional data is means countries. So we are collecting data for 4 countries for 12 years. It means each country has 12 observations, right? So then generally to test the panel root test should have large t-value. It means that the tie dimension here 12, right? So then normally there should be large t-value. Actually 12 is not that much large, but I'll test it using 12 observation because you need to see it, right? So how do we do the Levin-Lin-Chu test or LLC test to test the stationary level, right? So then, but if you are having like that t value, some are doing, some have collected data for 5 or 6 years, like 4, 5, 6 years for the previous 5 years with large number of countries. It means their t value is smaller but N value is large. It means they are collecting 20 companies. 20 company means N is 20, T is 5 years, right? So then they are having what we call the small number of T. T. Here we have 12 observation. 12 observation means 12 years they are considering for 4 countries. So then it is also not much, it's not that much large, but I'm doing it. But if you are having actually smallest amount number for the time series, I'm not highlighting. You don't not no need to do the what we call the stationary or the panel root test, but you cannot do it. So I'm not saying that you don't need to do the panel root test with your data set, but you cannot do, because in this EViews, it is better if you are having a large, the much value to do the panel root test, right? So then you can see the probability value is also 0. It's lower than the 0.05. So then it's okay to proceed the data analysis, right? So then we can test for the next variable as well. Based on these results, you can see p-value is 0.03. So this is a very small p-value. So much lower than common significance levels such as, that 0.05. So then based on this, the decision is that we can reject the null hypothesis. So then rejecting the null hypothesis means since the p-value is lower than 0.03, so then we reject the null hypothesis at the conventional significant levels. So then we can conclude that the panel data series does not have a unit root, and it's therefore stationary, right? So then as implication, we can say that the data statistical properties such as mean and variance and constant over time, right? So then we can test, so then for other variable as well from by the same way, right? So I'll take labor force. Then view unit root test, then okay. So then after you can see here the probability value is 0.23. So at the first level we cannot accept this. This is not stationary, so therefore we can again do the unit root test. Test type common root Levin-Lin-Chu, because this is balanced panel. So then test for unit root in first difference we can do. So then you can see the results. So at the first difference, the probability value is lower than the 0.05. It means this results, the null hypothesis is rejected at the first difference, right? So therefore the level of the stationary is what we call the panel data is stationary at the first difference for the labor force, right? And the third one is trade GDP, and then click on view, you need to test. Then first we need to test the unit root test at level. Here already selected and include test equation. Yes, here also the same for the first level. Sorry, the level, the probability value is 0.20 for the trade GDP. So then we need to test at first difference. Yes, unit root command is okay. Then the first difference, then okay. Yes, at the first difference, the probability value is 0.00. So therefore, we can say that at the first difference, the data, the panel data of the particular trade DTP is stationary, right? So this is how we need to do the panel unit root test. But as I mentioned earlier, so if you are having smallest number of T observations, actually, so uh, I don't say that no need to do the unit root test, but we need to test, we need to have some large number of T to do the panel root test. Otherwise, stationary value will be misled, right? So if you are willing to do the panel root test, you can do. So otherwise, you can do the balance part, right? So it is better you can test the stationary as well, right? So then this is the way how do we do the unit root test as panel unit root test by using live-in lin and choose unit root test, because this is panel balance panel, right? You can see this is balance panel, right? Okay, so then hope you got it. Anyhow, I'll again explain. So simply in your T and A value, you have to compare. So here T value is 12 and N is 4. So then simply you can't run the panel unit root test using any of these numbers, right? So because any of these tests, there's a minimum number of required to perform the test. Okay, so because the idea is that if your time dimension is short, it means T is short and N is large. N is means the number of, I mean, if you get the number of companies, the number of N is large. So then N is large, it means most you are suffering from heteroscedasticities than autocorrelations. But N is smaller, N value is small, but the time dimension is large. So then relatively impact of heteroscedasticity is smaller than the impact of autocorrelations. That is the main idea behind that. So in your case, sometimes you work with few years with large number of observation, right? 364 listed companies in Colombo Stock Exchange or somewhat the particular sectors. So then your T value is smallest, but N value is largest. Like you are doing for the research for 4, 3, 5 years like that. So then you don't need to perform a panel root test. So you can escape that part, right? Hope you can get it. Right. So then we'll see how do we do the regression analysis. So by using panel data, right? I'll close it. If you need to copy that, please copy the particular data into your sheet. So then now we can move to the regression analysis. You remember this is the equation we have. Yeah, this is the dependent variables, and then after these are the explanatory of the independent variables, right? So independent variables, and we have two independent variables. So then again I move to the uh, EViews. Then there you can see in the EViews top bar. So you can see the quick options. So they are click on estimate equation, estimate equation. And next you have to select, first you have to select the dependent variables of your finding, right? So what is your dependent variables is what GDP, just click G. It then you can see it's all the variables will be appeared with the highlighting the particular variables, then okay, and put a space. Then you know that we should have the intercept or constant value, then click on C. Yes, C, and then put a space, and the second variable is labor, sorry, yes, trade GDP. So then click on that variables and keep a space, and then after labor force, select that. So these are the variables and the equations we can develop as our initial equation. So then after this is actually panel data. So therefore you need to tick on panel options, right? Panel options. So there first we need to we need to run the model by using the panel option, right? So then as cross section, you need to select the random, right? Then we can test whether which model is more suitable. First, you can put random model, right? So then random, then okay. So then after you can see the results, right? You can see the results and p-value, the trade GDP p-value and the coefficient tables, and you can see the cross sections and the number of total panel balance panel, the observation 56. So then after you can see the constant value coefficient figure and trade GDP coefficient figure and the labor force coefficient value with the probability value, right? So based on this, the as per the random effect, the variables, both variables will be rejected. And also you can see the R square value as well, adjusted R square, because we already have discussed those things, right? But then we need to select whether this model is fixed effect model or random effect model. We got these results by clicking the random. So then to confirm this, we can do the Hausman test. So we'll see how do we do the Hausman test in this data. You need to click on view, and there you can see the options, right? So then after you can see here the fixed and random effect testing, and there you can see the third option is Hausman test. By clicking that, you can see the cross-section random is 0.02. So it means actually this value is lower than 0.05. So it means we need to test the results by using fixed effect model, because we need to test the random effect models. I'll show you. First, I will show you, and next I'll explain this. So you know that show you the percentage. Yes, this is the Hausman test results, right? So we need to select whether fixed effect model or random effect model is more suitable. I explained. So what is the difference in between fixed effect model and random effect model? So that is actually they vary with the correlations in between what we call the explanatory variable plus unobserved effect, right? You remember, I already have explained at the theoretical part. So please refer it. So because you need to mention in your report, because before we explain that part, before we explain the regression part, we need to explain what method or what model you use, whether it is fixed effect model or random effect model. That is must, right? So when you are doing your research report, when you are writing your research report, you have to highlight which model you have used. So then normally H0, it means null hypothesis is the differences in coefficient are not systematic, right? So then, of course, random effect is most appropriate. It means if the null hypothesis is accepted, means so we need to use the random effect model. So if alternative hypothesis is accepted, it means differences in coefficient are systematic. So then we need to select the fixed effect model, right? So you can see here, how do we select based on the p-value. If p-value is lower than what we call the particular value, so then we need to select the fixed effect model. Otherwise, what we call we need to go forward with the random effect model. It means if p-value is lower than significant value, so then we need to choose the fixed effect model. Otherwise, we need to choose the random effect model. So according to these results, you can see here, right? According to these results, so this is the conditions or the criteria for the panel data regression analysis. So according to these results, so you can see the probability value is lower than the required 0.0511. So therefore, if the p-value is less than the chosen significant level, typically 0.05, so then we need to reject the null hypothesis in favor of alternative hypothesis. So therefore, since p-value is here 0.029, right, is less than 0.05, we reject the null hypothesis and conclude that the difference in coefficients are systematic. So therefore, here this fixed effect model is more appropriate for the data than random effect model, right? Random effect model. So then you remember we did the regression equation by using random option, you remember? So then we find the values as well. So that is not appropriate because we have rejected the null hypothesis. You have to write that part in your report as well, right? Which method you have choose, right? I mean, whether it is fixed effect model or random effect model. So then the effect model is not appropriate. So then we need to do the fixed effect model regression equations. Again, you need to test the regression equation with the fixed option. How do we do that? So these are the results we got from the random effect model, right? Random effect model. So then after we did the Hausman test, how do we do that? Fix the random effect. Then after we test the Hausman test, their probability value is lower than 0.05. So therefore we assume that here the fixed effect model is more suitable. Then again click on estimate, right? The same results, click on estimate. Then after you can see the equation, right? Equations. And then click on panel options. You can see here we already have selected random effect. So therefore we need to tick on fixed effect and okay. So then you can see the results as for the fixed effect model. Here we see we need to select the fixed effect model. The reason is why the Hausman test value is lower than it, p-value is lower than 0.05. So therefore you need to interpret the results by using fixed effect model. So then here you can see if we test the result panel data by using random effect, so just you can see the R-square value. If you choose random effect model, R-square value is 0.05. It means 5% explained by the independent selected independent variables or dependent variable. But based on the Hausman test, we know that so random effect model is not suitable. So therefore, again we test. You can see just see the R-square value, right? So then we know that the fixed effect model is more suitable than tick on fixed effect model. And another thing, there's no any variables also accepted because p-value is greater than 0.05. So therefore, we cannot test the results in the random effect model because based on the Hausman value, right? Then again estimate. Then after you can see this model specification or equation specification, go to the panel options, then select fixed option, then okay. Then after you can see the results, right? You can see the results. R-square value has gone up to 0.37. It means 31% explained by the selected independent variables of the dependent variable. As well as you can see here, when it's come to the, I have already explained with you in the time financial modeling and forecasting subject, remember, then you know how do we interpret these results, right? So I'm not going to discuss in detail since you all are aware of this analysis part because I already have explained with you with the financial modeling and forecasting anyway. So then you can see the probability value for the trade GDP. It is greater than 0.08. It means there's no any effect from the trade GDP on the GDP present of the particular country. But when it comes to labor force, it is probability value is 0.01. So then it means that so there is a significant impact from the labor force on GDP. And also the R-square value is 31%. And also you can see the adjusted R-square and also F statistic and also the probability F statistic also 0.05. It means model is statistically valid because if the value is lower than 0.05 means that we know that model is statistically valid. And also you can see the Durbin-Watson value as well. It is in between, the value is 1.48. So we can conclude that there's no multi-collinearity problem. So then this is the regression result you need to show in your report, right? So you need to show in your report and based on this, you need to accept or reject your hypothesis. Clear? But before you mention this result, you have to mention, I again highlight, right? You need to mention which method you use, whether it is fixed model or random effect model and why it is. I already have explained in the theoretical part. I again refer that theoretical part at the beginning of this recording. So then you can understand the difference why we are testing the fixed effect model and random effect model. So this is the way how do we find out, how do we calculate the regression result, right? So then now we know how do we test the descriptive statistic and also if you need to test the panel rule test, how do we do that? right? Then by using the panel or root test, I will do it again, right? You remember based on that, actually, we can test the stationary, right? So if the particular p-value is lower than the 0.05 means the data set is stationary, and otherwise we can do it first difference level. And before that, we need to test it balanced panel or unbalanced panel. Based on that, we can do the living link Q test or inference test. Inference test, you remember I explained all the things. So this is the result. Then you can estimate it, and you can copy this data to the sheet, and then you can interpret this result, right? So if you need to rename it, right? So I just put it, okay. So therefore, then you can close it. Then you can just click on this equation. Then you can see the results, right? So if you need to save this document, you can see here the name option. So then you can put the name for the results and okay, right? So this is how we do the regression analysis, panel regression analysis by using EViews software, right? So this is easier, but you need to decide which method is more suitable. It is what we call the fixed effect model or random effect model. I am again highlighting, you need to mention it in your report as well. So then we'll see, now we know descriptive analysis and panel root test, if you're willing to do the panel root test. So, but please keep in mind, if your t-value is lower, no need to do that, because there is a requirement to, minimum requirement to test the panel root test. But if you are collecting data for 5 or 6 years for a large number of n observation, no need to do the panel root test. But definitely you have to test the Hausman test with multiple regressions. And also you can do the correlation part, right? Correlation part in between the variables. I will explain you how to do the correlation analysis in EViews, right? Here we have 3 variables. Select the variables GDP, labor force, and trade GDP. These are our variables, right? These are our variables. Then right click, and then as we did for the descriptive analysis, right click, open group. Right, sorry. Select the variables, right? Group GDP, labor force, and trade. And then click on quick. Then you can see here the group statistic, right? Group statistic. There you can see the correlation. Then click on the correlation. Then I have already selected the variable, right? I have already selected the variable. That is why the variables are here. Otherwise, you need to give the variables, right? GDP. So then you can see here the variables will be appear. First, you need to put the dependent variables. So then after independent variables, right? Trade, GDP, and next labor post. Then okay. So then you can see the correlation in between the selected variable, right? So in between, you know that, ne? So 1 point means the same variables, the GDP and GDP, it is equal to 1, and here also the 1. But in between GDP and trade, GDP, you can see the relationship. There is a actually weak relationship in between GDP and trade GDP. But when it comes to the trade labor force and GDP, you can see here 36% is there. It means there is a moderate relationship in between GDP and labor force. Likewise, you can interpret this correlation, right? Correlation as well. So this is how we do the correlation analysis. So these are the basic analysis tool you need to do in your research, right? So hope you can clear all the things are clear. I will explain that part by using another example, right? So the same analysis part I will explain with you by using the same analysis part. So here I use another variables. So you can see I have another worksheet. So this is similar to your observation, right? So I have collected data. Then you can see the company. company name, Abans PLC, 5 years data I have selected, I have collected, but it is better if you, what we call, you can code, if you wish to code this AEP likewise, as per your requirement, you can code it, or otherwise you can put it, the full name. As I mentioned earlier, you have to put the company ID like this, company ID, you can see here, I have put the ID for all companies, right, all companies. And then after years, right, years for the Abans Electrical PLC 2015 to 2019, and for the Access Engineering 2015 to 19. Likewise, I have collected 5 years data for all the companies, right? You can see, first thing you have to develop your Excel sheet like this, right? Please keep in mind, otherwise it will be complicated, right? First thing you have to develop the Excel sheet like this. So then after, you can see the dependent variable, I got selected ROE as dependent variables. Actually, this is hypothetical data, right? And also these are my independent variables, board size, column size, leverage, and board meeting. Just assume this. I'm testing these 4 variables. How do this variable impact to the dependent variable? So the financial performance, because we can measure the financial performance by using ROE. Hope you also have this kind of data set, right? Then first duty is what? You need to develop the Excel sheet like this. Then I'll again do the EViews. So then you have to open your EViews software. EViews. EViews. Then close it. And this one also close. Then you remember the path, file, imports, import file. Then after, you need to find out the particular document. I rename it as data sheet 2. Then after, you remember next and next. And here you can see, as I mentioned earlier, basic structure should be data panel. If you develop your Excel sheet in proper manner, the basic structure is data panel. Then finish. Then no. So then after, you can see the data set, right? Data set. First thing you have to do what? You need to do the descriptive analysis. Then I'll do the descriptive analysis. How do we do that? By pressing the control, you need to select the variables. So these are my independent variables, and this is my dependent variable. You remember it? And the variables are set as per the alphabetic order. So that is why you can see the dependent variable is at the last point. Then how do we do the descriptive analysis? Right click, open, group, and then after, you can see the all the required informations, right? And country ID also, you can see, that is the importance of giving country ID and their financial year. Then view, then descriptive analysis and common sample. Then you can develop the sheet like this. You can see the observations, 750 observations are there, and probability value, mean value, mediations, and maximums, minimums, standard deviation, skewness, cortis, everything is there. So then you have to interpret this based on these results, right? So what about the mean value of the board of meetings? Likewise, you need to interpret it, right? That's up to you. So this is the way how do we do the descriptive statistic, right? So definitely you need to include this result into your report, right? You can copy this data, right? Copy, and you can then you can receive this kind of option. So then okay, then you can copy this results to the your report. So if you need to rename it, you can name it descriptive statistic. Descriptive statistic. Then okay, error message is coming because we can't keep the spaces, right? We can't keep, or we can use capital letters as well. Descriptive statistic. Then okay. So then you can see the descriptive statistic also results also there. By clicking this, you can see the results. And also remember, then after, we can do the panel root test. Actually, so in here, T is 5. So then no need to do the panel root test. So no need to test the panel root test. But anyhow, I'll explain how do we do the panel root test. So then click on the particular variables and click on view. So there you can see the unit root test. And this is panel. So therefore we need to select on living link true. If it is unbalanced, so then we need to select inference and test. So therefore first we need to test for the unit root in level. So then individual intercept, then okay. So then you can see you will come this message insufficient number of observation encountered in unit root test. Then if you are having data set for 5 years, so you can't do the unit root test. So that is why I highlighted, right? You remember, so if you are having minimum number of a smaller number of t or time observation, so then definitely you will receive this kind of message. So that is why I mentioned that you can't do the unit root test as there is a requirement, right? So minimum number of required to perform this test. So then no need to test the unit root test if you are having this kind of, if you are receiving, if you are appearing this kind of message, so then okay. Then what we need to do, so then we need to do the regression analysis. You remember, right? So how do we do the regression analysis? Quick estimate equation. Then our dependent variable is ROE, then space, then constant, right? Then our variables we can select board meeting. Board meeting we have 4 variables and board size. So then after we have leverage and firm size. We have 4 independent variables, so the explanatory variables. So then we need to develop the specific equation or equation or regression equation that we have developed. So, and please keep in mind, if you are having 2 models, you have to test it separate, right? ඔයාලට model දෙකක් තියෙනවා. උදාහරණයක් දෙන්නකෝ සමහර අය financial performance එක measure කරනවා, ROE එකෙමුත් measure කරනවා, ROA එකෙමුත් measure. So then you need to test it separately, right? First you have to test for the ROE, then after second model you have to again develop for the ROE as well, right? ඔයාට තියෙන model ගන්නව regression equation වෙන වෙනම test කරන්න ඕනේ. Then the panel option you need to put the random, then okay. So then you get this kind of the final result like this, final results, right? And also you can see the R squared value and the probability test as well, right? You clear here? And the cross section include and period number of years 5 years and sample time period and also the date and everything you will see. And the dependent variables you can see ROE and the coefficient value, right? You can say that near the first one coefficient figure is 0.00, but probability value is 0.5. It is greater than 0.05 level, so then this variable is rejected. But when it comes with the final one, firm size, coefficient value is 0.02, then probability value also 0.05. But we cannot interpret results by looking this because we need to check whether, because we just test this results by using the random effect, but we need to confirm it. How do we do that? You need to test the Hausman test. For that, click on view and fix or random effect testing, click on Hausman test. Yes, then you can see the probability value is 0.0032. So therefore, we cannot use the random effect model because probability value is 0.000. It is lower than the 0.05. It means null hypothesis is rejected, alternative hypothesis is accepted. So therefore, we cannot interpret the results by using the random effect model. So therefore, we need to go forward with the fixed effect model. So again, we have to change the estimate equation. So this is the equation, then panel option. Cross section is fixed because Hausman test p-value says that we need to select the fixed effect model because it is it's lower than 0.05. You have to mention it. Then you need to put on the fix and okay. Then you can see the results. These are the actual results. And you can see here the R-square value also has changed. It is 70% explained by the independent variables. Right? So this is the real results. So we need to show this result in our research report, right? And also you know that the meaning of F statistic and probability F statistic and Durbin-Watson value. So I already have explained it earlier. And also based on the p-value. So then you need to interpret and you need to accept or reject your hypothesis based on this results, right? Hope you got the got this in clear manner. And then after You can name it and you can save it document. I'll rename it as regression, panel regression. Then after you can just clicking on this, you can open it. Then after I'll close it and you can just click on the results, copy and paste to the worksheet. And next we can do the correlation part. How do we do that? Click the variables, ROE, and then click on quick. There you can see the group statistic and correlation. Then you need to give the what we call the data set, right? First you need to mention the dependent variable, and then after all other independent variables, then okay. So then you can see the relationship. ROA and ROE, same, 1. And also you can compare the ROA and ROE. There is a negative relationship in between ROE and board meeting. Likewise, you can explain here. There as you can see here the positive relationship. Likewise, you can explain, interpret the results based on the correlation table. Right, so that's all about the regression analysis as well as the correlation analysis. So how now you know how do we do the panel data analysis by using the EViews software. Yes, of course, if you are having any question, you can contact me, right? You can contact me and for the explanations, right? I'll support you. So if you are having any question, you can directly contact me. You have the contact numbers and email. So then I will support you. So then with that, thank you so much and have a good day and have a fruitful session as well. Then hope you do your research by using this sessions, and definitely this recording also will benefit to you as well. Thank you so much and have a good day.